Now let's implement example of executor service. So I'll be creating two examples to show the executor service, and the two example, one with the runnable and the second one with callable. So let's implement the first example, which is with runnable. So the class name is executor runnable. Now let's create public static void main PSVM, and inside our public static void main we'll create a runnable, lambda expression, and inside this I'll be sleeping it for 1 second. So we have seen example of thread.sleep. Here there is a different way which we can do the thread.sleep is with the time unit. So time unit dot milliseconds dot sleep and 1000. So this is another way of sleeping instead of using the thread.sleep. I was complaining about the exception handling, so let's run with try catch. And at the end we'll print out finish executing. So out and thread dot current thread dot get name and plus finish executing at and local date time dot now. So it will print the time. Now let's call this service using executor service. So executor service executor is equal to executor dot new fixed thread pool. So we are creating a fixed thread pool of size 10. Now let's implement the first example, and we'll be using the execute method. So execute method does not return any features, it just call the execute. So let's print out first example. Executing task with execute. Method. And here we'll be calling executor dot execute, and the name of the task is Runnable. Now let's call using submit. So submit returns a future, and we'll be getting the values, and we'll be printing out the value which will be passing on with this executor service. So let's see how we will implement this. So system out and second example executing task with submit. Now submit method returns a future, and so what we'll be doing is that we'll be creating a future object, and this future will be returning a string. So string and result is equal to executor dot submit, and we'll be passing on the runnable here, and the result which we want is completed. This is the string which we want. Once the thread complete executing, then this is the result. It will be passed on to the result. Now I'll be doing while not of result dot is done. Is done is not blocking, so we are calling is done, and then here we are printing out the method return value plus result dot get. So in this case we are calling the is done, and then also we are calling the result dot get. This result dot get is blocking, so it will wait here until the result is available. Add exception to method signature, and then at the end executor dot shutdown. Now let's run this example. So here we see that first example executing task with the execute method, second example executing task with submit method, pool 1 thread 2 finished executing at this time, pool 1 thread 1 finished executing at this time, and the method return value completed. So we get the result, we pass on, when we run the executor.submit, this is the result which we want. And once this thread completely done, then we get this value, which is the method return value completed. Now let's implement this example using Callable. So let's create a new class, and the class name is Executor Callable. So in this example, we'll be creating a list of Callable, and we'll be running those lists of Callable using Executor service, and we'll be creating a list of futures where we'll be returning the values from each Callable, and then we'll be looping through that and get the results. So let's implement this example. So first create public static void main, and let's create our Callable, and Callable will return string. Callable is equal to and here we'll be sleeping time unit dot milliseconds dot sleep 1000, and here we're sleeping for 1 second. And once it is done with it, then we return current time is plus local date time dot now. So in this Callable we are returning a string, and this string will be in the future. So let's create an executor service now. Service executor is equal to executors dot new fixed thread pool, and thread pool, let's say it is only 1. So we just want to run one task for the executor service, and then once the task is finished, then we'll be then it will be running the next thread. So now we create a list of Callable, because we'll be running 2 Callables in this case. So string and create a task list, and this is equal to arrays dot as list Callable and Callable. So what it will do is that it will create a list of 2 Callables and will create a list, and this will be task list. So inside this task list we'll have 2 tasks, Callable, and then the second one is also Callable. Now let's print out first example using invoke all. So we'll be using invoke all. And here it will give me a list of future, and future object will hold a string because our callable return a string. So future object will return, which future object will hold a string. So results, let's have this list name is equal to results, and executor dot invoke all, and here we'll be passing on task list. So in this case, the executor invoke all and the result will be in the list of results. It's complaining about exception handling, so add exception to method signature. Now for we'll be looping through the futures. So for future string and result and results, and print out the result. Now the second example is calling this using submit. In this case it will be returning just one. So here this is an example of submitting using multiple tasks. Now let's see an example where we'll be just submitting one callable to the executor service. So here what we'll be doing is that first we'll be printing out executing callable task list using submit. Executing callable using submit. So because we are just running one callable, in this case it will just give me one future and string, and result is equal to executor dot submit and callable. And again while not of result dot is done, print out the method return value plus result dot get, and at the end we're calling executor dot shutdown. And here it is complaining about exception handling, so add exception to method signature. So let's go through this program. So we create an instance of callable, which is name is callable, and here we are sleeping for 1 second, and afterwards we are returning this string current time is local date time dot now. So this callable is returning this string which will be held in the future object. Then we are creating an executor object with a fixed thread pool of 1 thread, and then we are creating a list of callable because we want to run this as invoke all. So we are creating a list of callable and we are putting two callable, the same callable in that list, and using invoke all we are invoking this task list. So invoke all is a blocking call. It will wait until those callables are completely done. So once this callable is done, then it will come over here, and then now this results of future are in this results object. So we are now looping through that results object and printing out the result. Now here we are calling using executors or submit. Executed or submit is not blocking, so it will call this callable and will get this value and future result. So this will initially it will hold a value of null, because future means that at any given future point it will hold some value. And now we are basically waiting for this done method to return, and here we are printing out the value using return.result.get, and get is also blocking. So let's run this program. So here you can see that first example using invoke call, and then it waited for these to be completed, and then afterwards it printed out completed normally. And here maybe what we need to do is that, because it is printing the object instead of printing the value, so we can get result dot get. Now it will print the exact value. So let's run this program again. So it's saying that first example using invoke call, and then it waited, and once it gets the result from both the callables, and it printed out those values, and then afterwards executing callable using submit, and the method return value current time is this. So invoke call is blocking and submit is non-blocking.